Our future in space, a new frontier with new challenges. Humanity is entering an exciting era of space exploration. Ambitious missions like NASA's Artemis program aim to take astronauts back to the moon and eventually to Mars. This renewed effort is driven not only by governments but also by private companies developing powerful reusable rockets, making space travel more affordable and accessible to a wider range of people and organizations. However, this increase in space activity has created a serious problem: space junk. For over 60 years, old satellites, rocket parts, and other fragments have been left orbiting Earth. Traveling at incredible speeds, even tiny pieces can damage active satellites and threaten future missions. This growing debris cloud poses a significant hazard that must be addressed to keep space safe and sustainable for all users. To protect our future in space, international organizations are working on a two-part strategy. The first part is prevention. New international guidelines now require satellites to be removed from orbit within 5 years after their mission ends, replacing the older 25-year standard that allowed debris to linger much longer. The second part focuses on cleanup. Scientists are developing innovative technologies for active debris removal, including robotic arms to grab old satellites, giant nets to capture tumbling objects, and harpoons to secure large pieces of debris. These efforts are vital because if debris continues to accumulate, it could trigger a chain reaction of collisions, making some orbits unusable. Beyond managing debris, many experts aim to establish human colonies on the Moon and Mars. These colonies would help ensure humanity's long-term survival by creating a planetary backup in case of catastrophe on Earth. However, these environments are extremely hostile, with extreme temperatures, dangerous radiation, and no breathable air. To overcome these challenges, scientists are developing ways to use local resources, a concept called In-Situ Resource Utilization, ISRU. Innovations such as 3D printing habitats from lunar soil and extracting water and oxygen from Martian ice are making long-term settlement increasingly possible.